Okay, so for this first one, we're going to simplify this radical. So when we're looking at 108, we want to find the biggest perfect square that divides 108. You can type in the square root of 108 into your calculator, and if you get a nice perfect square, a nice whole number, that means that it is a perfect square. But if you type square root of 108 into your calculator, you get a decimal. So that means it's not a perfect square. So we need to look at our list of perfect squares. And you can keep going if you want, but basically you just need to have that list in your head. So if you want to write it at the top of your quiz or test, you can. So if you do 108 divided by 4, you're going to get 27. So 4 does divide 108, because if you do 108 divided by 4, you get 27. But we want to make sure it's the biggest one. So I don't think that's quite big enough, because 27 is a pretty big number left. So let's do 108 divided by 9. That's 12. So 9 does also divide 108, but that 12 is still a big number, so let's keep going bigger. So 108 divided by 16, that doesn't work because you get a decimal. So 16 does not divide 108. 108 divided by 25, that is also a decimal, so it does not divide 108. So you might be thinking we might be done, but let's try a couple more just to see. 108 divided by 36 is 3. So 36 is definitely the biggest perfect square that divides 108, because 3 is a small number. So we're going to split 108 up into 36 times 3. We can split that radical up into square root of 36 times the square root of 3. Square root of 36 becomes 6. Square root of 3 is not a nice number. If you type that into your calculator, you're going to not get a nice number, so we leave it there. There's technically an invisible multiplication sign there, but a lot of times we don't write that in our answers. We just write square root of 6, radical 3. For number 2, there's x's involved. So this works the exact same way. We're just going to separate our radical and our letters, our numbers and our letters. So first, let's simplify the square root of 125. This is going to work the same way as the last problem. Okay, so you're going to look for the biggest perfect square that divides 125. You might be thinking 25 sounds like a good option, so let's do 125 divided by 25, and that gives us 5. 5 is a pretty small number, so that's definitely our biggest perfect square. So we're going to split 125 up into square root of 25 times the square root of 5, because 5 times 25 gives you 125. And then we're going to leave our square root of x squared as square root of x squared. Now we're going to leave it that way because the square root of x squared just becomes x. We can't do the square root of 5, so that's going to stay the square root of 5. We can, but it's going to be a decimal. So we'll leave it as the square root of 5. And the square root of 25 is 5. Now this is technically our answer, but we don't usually write our answer like this. We put the numbers that are outside the radical, so the 5 and the x, together in the front. And then we put anything under the radical. So that would be our answer here. When we have multiplication for radicals, it's usually best, you can simplify it first, but it's usually best to multiply what's under the radicals together first. So we can do 10x times 8x first. That will give us 80x squared, because we're multiplying 10 times 8. You can add the exponents, or you can just think x times x is x squared. Now we're going to do what we did with this problem here. We're going to break this up into the square root of 80 times the square root of x squared. The square root of 80, we're going to find the biggest perfect square that divides 80. You don't want to break it up, like 8 and 10 is tempting, right? You could, 8 times 10, sure, that is 80, but neither of those are perfect squares, so you don't want to use 8 and 10, okay? You want to make sure you use a perfect square. So let's see, 80 divided by 4, that's 20. So 4 works, but I'm not sure that's big enough. 80 divided by 9, that's a decimal, so that does not work. 80 divided by 16 is 5, so that's our good one there. So 16 times 5 is going to be our, 16 is going to be our biggest perfect square. So we'll break up 80 into 16 times 5. We'll leave the square root of x squared as x squared. Square root of 16 is 4. We're going to leave the square root of 5 as square root of 5, because if we type that into a calculator, we get a decimal. And the square root of x squared becomes x. So now to write our final answer, we're going to put the 4 and the x together in the front, and then we'll leave the radical 5 underneath. So that's our answer. For number 4, you could divide 121 and 5 first, but that's not going to give you a nice number if you divide that in your calculator. It's like 13.4. So instead, what we're going to do is we're going to do the square root of 121 and the square root of 9, because those are nice, perfect squares. Square root of 121, if you type that into your calculator or know it's a perfect square, that's going to give you 11. Square root of 9 is 3, and so that would be our answer. For this problem number 5, we could simplify the radicals first, and that's possible, but it usually gets really messy. So it's going to be easier if we divide first and then simplify. So we're going to divide everything under the radical first, and notice how it's all under the big radical. Okay, so we're going to do 72 divided by 8 first. 72 divided by 8 is 9. X cubed divided by x, we're going to subtract the exponents, so that'll be x to the 4th, and this is still under the radical. So we're almost done, but we need to make sure our answer is simplified. So again, this is now like problem number 2. Okay, so we're going to separate square root of 9 and then x to the 4th, because those are, separate the numbers and the letters. Square root of 9 is nice, that just becomes 3. We don't have to simplify that, that does simplify automatically. And then the square root of x to the 4th, it doesn't just become x because it's not an x squared, but we can break up because there's 4 x's there. X times x times x times x times x, right? There's 4 x's multiplied together. So that means we could break it up into 2x squareds under the radical, because now that's 4, right? So the reason why we broke that up is because the square root of x squared becomes x. This square root of x squared becomes x, and then we have a 3 in the front. So this one actually becomes 3x squared when you multiply 3 times x times x. All right, let's look at number 9. Okay, so, oops, sorry. Let me move this around here for a second. For, not number 9, number 6. We're going to look at number 6. So for this one, remember you can only add and subtract radicals if they have the same number under the radical. This one has a 12 and this one has a 75. So we're not going to be able to subtract those right now. So instead, we'll try to simplify each of them first. So let's first start with 4 radical 12, and then we'll simplify 2 radical 75. Okay? So first, let's start with 4 radical 12. 12, the biggest perfect square that divides 12 is 4. 4 times 3 is 12. So we're going to break this up into the square root of 4 times the square root of 3. Now we do have this 4 hanging out in front, but remember, that's a multiplication sign, invisible multiplication sign between there. So make sure to keep that 4 in the front. The square root of 4 is 2, so this will be 4 times 2, because that was being multiplied. And then we can't do radical 3, so that's going to stay radical 3. 4 times 2 is 8, so this will be 8 radical 3. So that's the simplified version of 4 radical 12. That becomes 8 radical 3. So now we're going to do the same thing with 2 radical 75. So we want the biggest perfect square that divides 75. Okay. Biggest perfect square that divides 75 is 25, so we can break that up into 25 times 3, all under the radical. Sorry, that's a little messy. Don't forget this 2 in the front. Remember, it's being multiplied, so bring it down. Square root of 25 becomes 5. We can't do the square root of 3. That's not a nice number, so it's going to stay square root of 3. And then don't forget the 2 in the front. We're going to multiply the 2 and the 5 together because that's what it says to do, and so we'll have 10 times radical 3, or 10 radical 3. So that's going to be what 2 square root of 75 simplified down into. So now we have to ask ourselves, can we subtract these now? Now we can, because they have, Because they have the same number under the square root, they both have 3. So now we can subtract them. So we can do, and it's just like subtracting, like if you had 8x minus 10x, that becomes negative 2x, right? So it's just like adding and subtracting like terms. You're going to subtract the numbers in the front. So we're going to do 8 minus 10, which is negative 2, and the radical 3 just stays the same. All right, last one. We're solving an equation now for D. So we solve this equation the same way we usually would. We're going to get rid of the negative 11 and the 4 first. You have to make sure you do them in the right order. So be sure you do plus 11 first. That's going to give us 4D squared is equal to 44. We can't take the square root of both sides yet. We got to divide by 4 first on both sides. Now we'll have D squared is equal to 11. Now that the D squared is by itself, we can take the square root of both sides to get rid of that squared. That's going to make the square and the square root. They're going to undo each other, but don't forget to put a plus or minus in front of your square root. Anytime you do that to two sides of the equations, you got to put a plus or minus in the front. So then we'll have D is equal to plus or minus the square root of 11. Now square root of 11, if we could simplify it, we would have to, but it does not simplify because it doesn't have any factors. So that's it.